So good morning everyone. In this video we are going to see about basic introduction and classification of polymers. Okay, what are polymers in general? A large molecules formed by repeated units of small molecules. That small molecules are generally termed as monomers. So this is the definition of polymers. The name itself we can simply define as many parts or many units of a substance bonded together to give you a very long chain. That's called polymer. So generally it is a macromolecule by structure. That's why it is very big in size, since it is very long arrangement of small substances bonded together. That's why it is generally called as macromolecules. And by we can say it as semi-crystalline by behavior. That's the main characteristics of polymers. It means it is having both crystalline as well as amorphous nature, ordered structure as well as disordered structure. Generally that is crystalline and amorphous. Example: polyethylene, which is having very high strength, and polystyrene, which is having a good flexible by behavior. These are some of the examples of polymers basically we can see, and how it is classified. So classification: polymers are generally classified based on their source, based on their thermal behavior, how it is thermally behave. Okay, and based on their mechanism of polymerization, whether it is addition or condensation. So based on their properties, based on their chemical structure, so how the structure deals with that, and based on their tacticity. These are some of the general classification of uh, polymers by their versatile behavior. So source, it is a natural, whether it is available naturally as well as how it is prepared, that is synthetic. Thermoplastic, thermosetting, which is having regain its original shape, that is thermoplastic. Thermoset, it never regain its original shape. That's based on a glass transition temperature, like that. And how it is uh, bonded, that is a whether formation is through addition or condensation, like that. Addition means without any removal of material or substance, small substances, that is addition. Condensation, removal of water molecule, like that. And how it is structure looks: fiber type, plastic or resin type, elastomers type, that is properties. Based on the properties, its behavior. And chemical structure, whether the chain looks straight, linear, or cross-linked, we can say, or branched, like that. These are the some of the chemical structures that a polymer deals with. So linear or branched, like that. And the tacticity, whether it is isotactic, symbiotic, and atactic, means where the side chain, or where the functional group or side group, we can simply say how it is attached to that carbon atom, whether it's one side or opposite side, like that. It is classified as a tacticity behavior. So these are some of the classification, as we saw in the previous slide. Some of the examples are natural, synthetic, that is cellulose, synthetic, polyethylene, and thermoplastic and thermosetting. Thermosetting, generally we know very well about epoxy resins, which are one of the versatile material that can be used everywhere. And also thermoplastic, polyvinylidene difluoride. It is very famous polymer due to its flexible nature. Okay. And addition, polyethylene, so without any removal of small molecules. And condensation, with the removal of water molecule, so polymers are being formed. And some of the main property is fiber type, like that. So we have seen some of the sim images of fiber type polymers also here. So these are some of the classifications of polymers. And polyethylene, that's example for linear polymer chain. And another one is branched, also we can viewed in this slide. And tacticity, we used to tell where it is bonded to the which direction, we can simply say the same direction. You can see the isotactic. Oppositely adjacent carbon atoms is symbiotic that is phenyl ring is attached to the carbon atoms. And finally atactic, how randomly the side groups is attached to the carbon atom. These are some of the examples of tacticity. So how it is bonded to the main array of carbon chain in the polymer. Okay, so these are some of the classifications of polymers. So why we need polymers? Due to its thermal behavior, due to its mechanical behavior, polymers are being widely used in day-to-day life in everywhere. Okay, thank you so much for being watching this.